Hello everybody, my name is Noam Slonim. I'm the principal investigator of Project Debater from IBM Research AI. And as you know, in IBM Research, we have this tradition of grand challenges in artificial intelligence. Back in the 90s, IBM introduced Deep Blue that was able to defeat Garry Kasparov in chess. In 2011, IBM introduced Watson that defeated the all-time winners of the TV trivia game Jeopardy. And just a few days after this event, an email was sent to all the thousands of researchers of IBM across the globe asking us what should be the next grand challenge for IBM Research. And I was intrigued by that, so I offered my office mate at the time to brainstorm together, and this is what we did. We sat in the office in Tel Aviv, and we raised many different ideas, and at some point, towards the end of the hour, I suggested this notion of developing a machine that will be able to debate humans, and that this is how we will demonstrate the technology through a full live debate between this envisioned system and an expert human debater. This sounded better than all the other thoughts that we had up to that point, so we decided to submit that, and we submitted a single slide describing this project, and this was in February 2011, and a year later, eventually this proposal was selected as the next grand challenge for IBM Research. And we started to work with a small team that gradually expanded, and after nearly 7 years of intensive work, dedicated solely to this mission of developing a machine that can debate humans, we finally demonstrated the system to the general public for the first time in an event held in San Francisco at the end of 2019. And it was a full live debate between this system now being called Project Debater and one of the legendary debaters in the history of university debate competitions, Mr. Harish Natarajan. Sorry. And it was surprisingly reminiscent to the vision we had on that single slide back in the office in Tel Aviv quite a few years earlier. It was in front of a live audience of around 800 people, mainly top journalists from all the top media outlets in the world. And it was also broadcasted live on the internet, so it drew massive media attention, more than 2.1 billion social media impressions, and a lot of coverage in videos, press articles, and so on and so forth. And while the full live debate is available on YouTube, what we will do next is watch 3 minutes out of this debate, and then discuss the underlying technology. But first of all, here is the premise. The debate starts with a motion that defines what we are debating about. In the San Francisco event, the motion was whether or not the government should subsidize preschool. Importantly, this topic was never included in the training data of the system. And then after the introduction of the motion, we are on side government, Harish is on the opposition. We have 4 minutes opening speeches for each side, 4 minutes rebuttal speeches, and 2 minutes closing statements for each side. So all in all, pauses included, we have around 25 minutes of a discussion between man and machine. And let us now watch just 3 minutes out of this debate, and then get back to the presentation and discuss how the system actually works.
Greetings, Harish. I have heard you hold the world record in debate competition wins against humans, but I suspect you've never debated a machine. Welcome to the future. When we subsidize preschools and the like, we are making good use of government money because they carry benefits for society as a whole. For decades, research has demonstrated that high-quality preschool is one of the best investments of public dollars, resulting in children who fare better on tests and have more successful lives than those without the same access. Secondly, a few words about poverty. While I cannot experience poverty directly and have no complaints concerning my own standards of living, I still have the following to share. Regarding poverty, research clearly shows that a good preschool can help kids overcome the disadvantages often associated with poverty. The OECD has recommended that government subsidize pre-primary education to boost performance in poor areas.
Well, thank you very much, everybody. It's a pleasure to be here for this historic event. And it certainly was a pleasure to listen to Project Debater. There was a lot of information in that speech and lots of facts and lots of figures. The problem, though, is the reality of subsidizing preschools is one which does not deal with the underlying problems in society. If you massively increase the number of people going to preschool, they're all going to be the ones going to the high-quality preschools. In a competitive environment at the age of 3 or 4, when you're learning that that other child is potentially better than you, when you realize you aren't necessarily as talented as someone else, that huge psychological damage for many children may mean that preschool is actively harmful.
Among other things, I think Mr. Natarajan suggested that preschools should not be subsidized because this will reduce their quality. I would like to offer a different view. I disagree with my opponent. Subsidizing preschools will have no negative effect on their quality. If anything, the opposite is true. One of many reasons is that subsidizing attracts more skilled and qualified people to the field, improving the quality of preschools for all. My opponent claimed that preschools are harmful. I believe my argument suggested that the benefits outweigh the potential disadvantages. I touched upon 3 issues: children, students, and crime. Specifically, I noted that preschool education improves children's development. In addition, I suggested that attending preschool helps students succeed. And a final point to consider is that preschool can prevent future crime. We should subsidize preschools. Thanks for your attention.
The short answer is given in the following slide, and let me take you through that. So the system has 2 major sources of information. The first is a large collection of around 400 million newspaper articles from the LexisNexis corpus. And when the debate starts, the system is using various components in order to pinpoint short pieces of text within this massive corpus that satisfy 3 criteria. They should be relevant to the topic. They should be argumentative in nature, that is not just relevant, but further argue something about the topic. And finally, they should support our side of the debate. After hopefully finding these texts, the system is using other capabilities, for example, text clustering, in order to glue these short pieces of text together into a meaningful narrative. The second major source of information for the system is a unique attempt trying to capture the commonalities between the many different debates humans are having. So this is a collection of thousands of more principled argumentative elements that we developed over the years. And when the debate starts, the system is navigating, so to speak, in this knowledge graph, searching for the most relevant principled arguments, aiming to use them in the right timing. So just as an example, imagine that we are debating whether or not to ban the sale of alcohol or whether to ban organ trade. In both cases, the opposition may argue that if we ban something, we are at the risk of the emergence of a black market, which by itself has a lot of negative implications. So the black market argument is a principled one that can be similarly used in very different debates. And one may naively assume that this is just a keyword matching thing, but of course this is not the case. It's not that every time that we debate whether or not to ban something, we can use the black market argument. Think, for example, of a debate about banning internet cookies. Obviously, we will not expect a black market of people selling internet cookies at street corners. So the system really needs to develop a more subtle understanding of the human language in order to properly identify principled arguments that are truly relevant to the debate that we are holding. And finally, the system should also respond to the opponent arguments. This starts by listening to the words articulated by the human debater. And for that, we use the Watson speech recognition capabilities out of the box. However, obviously, we should go beyond the words and understand the main claims that the human debater is raising. And to that end, we developed an arsenal of techniques, most of which rely on the same principle of trying to anticipate in advance which arguments the opposition might use, and then listen to determine whether indeed the opposition was making these arguments in order to respond accordingly. So this was a very high-level description of how the system operates. And of course, the challenge is that many things need to succeed simultaneously in order for the system to perform well in a real debate. And as mentioned, we started to develop the system in 2012, and it took us 4 years to hold the first live debates. This was in 2016. And at that time, the system was still not making a lot of sense, often drifting from the topic, raising arguments that support the side of the opposition and so on. But from this toddler level performance in 2016, we made it to a decent university level performance in 2019. That is from nursery school to university in only 3 years, which was very interesting to observe. And beyond the live demonstrations of the system in San Francisco, we recently published the first paper that describes the project debater system in its entirety and further reports the results of a more systematic evaluation of the performance of the system over nearly 80 different debate topics. And this paper was featured on the cover of Nature 2 months ago, and we can share it with anyone who is interested to learn more about this project. And furthermore, as part of this paper, we started to share for the first time many of the underlying capabilities of Project Debater, and you can hear all about it in the following tutorial that presents these capabilities and how to use the relevant APIs. Finally, I started this presentation by discussing earlier grand challenges, and indeed grand challenges are present in artificial intelligence research from day one. Back in the 50s, Arthur Samuel from IBM started to develop the first software that can play checkers. Later on in the 80s, Jerry Tesauro, still in IBM Research, developed the world champion software in backgammon. And in the 90s, we had Deep Blue playing chess, and more recently, AlphaGo defeating human champions in Go. However, as we mentioned in the paper, we argue that while all these board game challenges were highly instrumental in pushing the boundaries of artificial intelligence, they still lie in what we refer to as the artificial intelligence comfort zone. There are several reasons to this claim, of which I will mention only one. When a board game is done, we know who won the game. This has important implications. For example, we can hold millions of versions of the system and enable them to play one another. And since after each game is done, we know who won the game, we can use this signal to improve the system. When a debate is done, we do not necessarily know who won the debate. It is not always even clear how to define that, since debate often contains a lot of subjective elements, and therefore we cannot use this path, and we need to search for other ways to make progress. Thus, Project Debater is certainly not in the comfort zone of artificial intelligence. Rather, it lies in a different territory in which humans are still better. Humans still prevail. But from the perspective of a scientist, this is actually good news, because it means that we still have many open questions to consider. And by that, I will end, and thank you for your attention.